Hi, Ann. Welcome to Clear and Concise. Let's have a look at this question. The rate of convergence of Newton's method for root finding is typically. There are several root finding methods such as bisection method, secant method, false position method, or this is also called as regular falsy method, and Newton-Raphson's method. Among these are the most widely used root finding methods among the engineering community. Now let's understand what is meant by rate of convergence. Rate of convergence describes how quickly the root x is approaching its true value with the increase in number of iterations. This is measured by using absolute error En, that is equals to modulus of the estimated root at nth step minus its true value. This is absolute error. The rate of convergence describes the relationship between absolute errors at n plus 1th step to absolute error at nth step. Depending upon this n value, we classify rate of convergence as linear, superlinear, quadratic, or something else. For quadratic, n is equals to 2. That is, greater the value of n, the quicker the rate of convergence, means the assumed or estimated root very quickly approaches to its true value. Example is Newton's method. For Newton's method, the rate of convergence is quadratic. N is equals to 1 for linear rate of convergence. Example is bisection method. For bisection method, the root converges to its true value linearly. At each step, the error value reduces by half to approach its true value. In the case of superlinear, n lies between 1.5 to 2. In between 1.5 to 2, it is 1.6 for secant method. So it is neither linear nor quadratic. It lies in between, that is 1.6. So we call it as superlinear because it is better than linear and less than quadratic. So we call it as superlinear. For regular false method, n is almost linear. It is very near to 1, or like it is in between 1.1 to 1.2 for false position method. So the correct answer for rate of convergence of Newton's method is quadratic.